Okay, for these, I didn't have enough space on here to like write out all the directions. If you wanted to do these on a separate sheet of paper, you could, or if you can write small, that's fine too. I want to find the distance between these parallel lines. So this is actually like the second example that we did. What I need to do first is I need to graph those, and I'm going to have to solve for y to be able to graph those. So I have x plus 3y equal to 6. So I'm just going to go ahead and solve that for y quick. And then divide by 3. So y equals negative 1/3 x plus 2. And I'm going to graph that. So I'm going here, and I'm going down 1 and over 3, down 1 and over 3. And I'm going to just go ahead and kind of fill out this graph with that so I can see where that entire line is. And then for the next one, again, I'm going to have to solve that for y because it's not already set up in that way. So x plus 3y equals negative 14, and I'm subtracting x from each side. So 3y equals negative x minus 14, and dividing each of those by 3. This one doesn't work out to be quite as nice because of this fraction here. I'm going to have negative 14/3, and if you'd rather think of that as negative 4 2/3, that might be kind of helpful to you when you're thinking about like how we're going to be graphing this. So I'm going to just kind of do an approximation here. Negative 4, 1, 2, 3, 4, and negative 2/3 is right around here. And then what I can do is I can go down 1 from there and over 3 and just kind of keep continuing that pattern. Up 1 and to the left, and then what I can do is I can graph that. So I have my straight line tool, and again, it's not a huge deal that you have that like 100% exact. I would not be using that one. I would pick the y-intercept here and go ahead and go from that. So I have my two equations. This is the equation of that top one, and this is the equation of that bottom one. And in this case, it might be helpful to you to go ahead and write those out. So if you remember our second step, we need to pick a point, and we need to write the equation of the line perpendicular. So I'm going to just choose this point because it's not negative 4 2/3, but I could be choosing that one and kind of going this way. We would get the same answer. You just have a little bit more work with fractions. So I'm going to say that I want to find the equation of the line that has the y-intercept, or goes to the point 0, 2, and the slope is going to be 3. And if you want to graph that first, you can. This one here is not too bad to graph. We can kind of see where those cross. But again, we're going to want to make sure that we have that exact location when we set up our system of equations. And it has that slope, so I'm going to write out that y equals 3x plus 2. Now I need to figure out what that exact point right here is. So I am going to find the answer to this system where these two lines intersect. So yes, you do have some fractions to deal with here. I'm going to use substitution and just set this part equal to that part because they are both equal to y, and I can do that. So 3x plus 2 equals negative 1/3 x minus 4 2/3. So I'm adding 1/3 to each side and subtracting 2. So I have 3 1/3 x equals, this is going to be negative 6 2/3. And when I divide it, it actually ends up not being quite as bad as what you initially might think. This does end up being exactly at negative 2 for the x value. And then I can choose either one of those, and I'll go ahead and choose the easier of the two. When I plug that into this, I have 3 times negative 2, which is negative 6, plus 2, so y equals negative 4. So this does end up being exactly at that point, negative 2, negative 4. So even though this was kind of nasty, it worked out a little better in the end. I'm almost done because remember the goal is to find the distance between these two lines. So I need to find the distance between this point here and this point here, which was at 0, 2. So I'm going to use the distance formula to do that. So the distance formula, I'm subtracting the x values squared plus the difference of the y values squared. I have negative 2 minus 0 and negative 4 minus 2. This is going to be negative 2 squared, which is 4, and negative 6 squared, which is 36. The answer to this is the square root of 40, or again, if you'd rather write this out as a decimal, that's about 6.32 or 6.3 depending on how you're rounding. If the directions don't say, I do not care. For this one here, find the distance between the line that contains these points. So I will sketch in that line real quick. So this line here, my first step will be to write the equation of that line, but I'll graph this point first. So I need to find the distance between that line and this point. So that distance, remember, is going to be like that perpendicular. So to write that equation of the line that goes through these 2 points, I'm finding slope first. So 5 minus 0 over negative 5 minus 0. The slope is going to be 1 over negative 1, which is just negative 1. And it gives me the y-intercept, so I would just go with the y-intercept being 0. So the equation of that blue line is y equals negative 1x, or you could just write negative x. And it goes through this point. So my next step is to write the equation of the line that goes through this point. And I know that it's going to be perpendicular, so I know it's going to have an opposite reciprocal slope. So the slope is going to be positive 1, and it goes through the point 1, 5. If you would like to sketch that out first to just kind of see, you'll actually be able to tell exactly where that y-intercept happens. Again, I'll show you the algebra just in case you can't tell on one of these. You can use point slope form. Y minus the y value equals the slope times x minus the x value. So y minus 5 equals x minus 1, and adding that 5 over. That red line has an equation of y equals x plus 4. And you can tell that by this graph, that y-intercept is 4. Just wanted to show you the math behind it. So now remember what our goal is we need to find out exactly where this point is. Again, for this picture, we can see where that is. If you can't tell exactly where it is, like you couldn't tell on that second example, we need to write the system of equations. We need to figure out where this line intersects that one. So I'm going to use substitution to do that. Negative x equals x plus 4. So I'm going to subtract x from each side. Negative 2x equals 4, or x equals negative 2. Plug that into either one. I just plug it in here. So y is the opposite of x. So y is going to be positive 2. This coordinate being at negative 2, positive 2, and I want to find the distance between that and this point here at 1, 5. Distance formula would let me do that. Subtract those x values. So that's going to be 1 minus negative 2 squared, plus subtract those y values. So that's 5 minus 2, and that's squared. So this is going to be 3 squared plus 3 squared. So the square root of 9 plus 9, that is the square root of 18. And if you would like to change that, you can. That's going to be, what is that going to be? approximately 4.24 units. So I don't know about you, but I find this very satisfying when you do all of this work and you're able to get the right answer at the end. By all means, you'll be checking these each and every time to make sure that that is the case. And please, please, please let me know if there's one that you can't get. I would love to help you figure out what your mistake is.